Okay, class, this is the example problem that I posted on the Blackboard site. You can download this. I'm going to sketch this out for us for the solution procedure. Let's see, we've got a cylindrical tank. It initially contains 2,500 kilograms of a liquid whose density is 10 kilograms per cubic meter. There are no inlets, only an exit. So we've got an exit rate. We got liquid leaving the tank at a rate of 30 kilograms per minute. My initial mass in the tank, they said, was 2,500 kilograms. We've got an initial height to Z0, and we want to find out how long it takes to drain the tank down to a height of 4 meters. So let's figure out the initial height of the liquid in the tank, Z naught. So we've got the mass of the liquid in the tank is simply its density times the volume it occupies. So the volume it occupies is the mass of the liquid in the tank divided by the density. So working this out, I've got 2,500 kilograms of liquid in the tank. Its density is 10 kilograms per cubic meter. So the volume that the liquid occupies is 250 cubic meters. That's equal to the cross-sectional area of the tank A times the height Z. So the initial liquid height in the tank is going to be Z is equal to the volume occupied divided by the cross-sectional area A. So that's going to be 250 cubic meters divided by 20 cubic or square meters. So that gives us a liquid height of 12.5 meters initially in the tank. So to figure out how long it takes to drain down, we've got to figure out how much mass comes out. So at a height of 4 meters, we can figure out the amount of liquid in the tank at that point. So the mass would be equal to the density times the volume. The volume at 4 meters is going to be 20 square meters times 4 meters of height. That's simply 80 cubic meters. And the mass at that height is going to be 10 kilograms per cubic meter times 80 cubic meters. Or that's going to be 800 kilograms of liquid in the tank as it drains down from initial height to 12.5 meters down to 4 meters. So let's set up our general equation. The time rate of change of mass and the control volume is equal to, since there are no inlets, I've just got the minus the one inlet, m dot E. So separating and integrating, I've got dm is equal to minus m dot E dt. So my initial mass is 2,500 kilograms. My final mass is 80 kilograms. So integrating here, I've got 800 minus 2,500 kilograms is equal to a minus 30 kilograms per minute times my unknown time dt. So solving for dt, I get 800 minus 2,500 divided by a negative 30. So plugging that in, it gives me a negative 1,700 divided by 30. And that gives me 56.6 repeating seconds or minutes. You guys work that out and see if you get the same thing. There'll be a second part to this problem as part of the homework. So if you have any questions, contact me. Thank you.